Welcome to this video about aircraft speeds. This is the second video of two videos, and this video is about the practical side of aircraft speeds. The objective of this video is to learn about aircraft speeds in practice. What speeds will an aircraft fly during a flight? Let's look at the speeds during takeoff. Can you remember what are the V speeds for takeoff? Watch this animation and see if you can guess what V1, VR and V2 mean. V1 is the speed at which a pilot makes a decision to continue the takeoff or stop on the runway. We can call this the go or no-go decision speed. VR is the airspeed when an aircraft can safely leave the ground. V2 is a speed to fly for the best angle of climb. Aircraft speeds during initial climb. There are three types of climb. Vx is the airspeed that gives the best gain in altitude for the shortest distance. This means that Vx gives the aircraft the best angle of climb, also called the best climb gradient speed. Max angle climb is useful if there are obstacles close to the airport, if an engine fails, or for noise abatement procedures. Vy is the airspeed that gives the best gain in altitude for the shortest time. This means that Vy gives the aircraft the best rate of climb, also called the airspeed for the best vertical speed. The normal climb is usually flown by an aircraft after initial climb and is either 250 knots or the best economy climb speed. Each type of climb can be selected by the pilot in the flight management computer. The flight management computer will calculate the airspeed for each type of climb. After takeoff, an aircraft will fly at a speed of V2 plus 15 to 25 knots until passing acceleration altitude. Acceleration altitude is an altitude between 1,000 and 3,000 feet depending on noise abatement procedures and obstacles. Aircraft speeds during the climb. After acceleration altitude, the aircraft will follow any SID speed restrictions and then fly 250 knots until passing 10,000 feet or faster if cleared by ATC, and then fly the best economy climb speed to the cruise level. During the cruise, in the cruise, the aircraft will fly the best economy cruise speed or any ATC speed restriction. If there is turbulence, the aircraft might fly the speed that is recommended for flight in turbulent air. During the descent, During descent, the aircraft will fly the best economy descent speed, turbulence speed, or any ATC restricted speed. Below 10,000 feet, the aircraft will fly 250 knots unless cleared for a different speed by ATC. Now let's look at the economy speeds. These are the airspeeds that the pilot will fly to try to save money for the airline. How does the pilot work out the most economical speeds to fly? Normally, the airline company will calculate a cost index for each aircraft type and maybe for each route. What is cost index? The costs of operating an aircraft are maintenance costs, crew costs, other fixed costs, and fuel costs. Normally, these costs are split like this. So the cost index is time-related costs divided by fuel costs. Airline companies calculate all these costs and calculate a cost index. When time-related costs are high, an aircraft will fly as fast as possible. When fuel costs are high, an aircraft will fly at the best fuel consumption speed or the best endurance speed. How does a cost index work? Each airline will calculate a cost index, and the pilots will use it in the flight management computer to calculate the most economical speeds for the climb, cruise, and descent. Entering 0 for the cost index results in maximum range airspeed and minimum trip fuel. Fly at best fuel consumption speed. We can see here cost index of 0 in the climb will give minimum fuel, maximum range in the cruise, and in descent the power will be idle and they will fly at the maximum lift to drag ratio airspeed. Entering the maximum value for cost index results in minimum time speed schedule. Fly as fast as possible. Let's look at an example. This is for a Boeing 757 aircraft. Normally, the cost index is not 0 or maximum, but it is somewhere in between. In this example, cost index 70 would be used by the 757 pilots, and it will give them a climb of 312 knots, decimal 794 Mach. In the cruise, decimal 794, descent, decimal 80 and 313 knots. This would be the best balance between the fixed costs and the fuel costs. Cost index can also tell the pilots which cruise level is the best to fly to request from ATC. You can see in the table opt, which means the optimal best level for cruise. Recommended means the recommended airspace level to request from ATC. Max means the maximum level that the aircraft will be able to cruise at the selected speed. Pilots will always want to fly as close as possible to these speeds because this saves money for their company. Early or late descents and speed restrictions normally increase costs for aircraft and the airline company. Let's now look at the speeds during final approach and landing. Aircraft must slow down from descent speed to the landing speed. So how do the pilots do this? First of all, what is Vref? Vref means the reference landing speed or velocity and is the speed the aircraft must fly when landing. Vref is 1.23 times the stalling speed in the landing configuration and at the actual aircraft weight. If the aircraft is faster than this speed, the landing run will be longer than the distance given in the aircraft's performance manual and could mean that the aircraft runs off the end of the runway. So to reduce speed to the Vref speed, pilots must lower the flaps slowly until the flaps are in the landing configuration. These are the manoeuvring airspeeds for each stage of flap. This example is for a Boeing 737-800. Pilots can select flaps in stages as shown here. This picture shows the primary flight display. The airspeed indicator is on the left-hand side. The green numbers here show the manoeuvring speed for the related flap setting. So in this example, flap 10 manoeuvring speed is 175 knots. Pilots will normally fly at the manoeuvring speed or slightly faster for the flap setting that has been selected. The yellow lines here and here show the maximum and minimum manoeuvring speeds for the selected flap setting. The red dotted symbols show the maximum and minimum speeds for the selected flap setting. Vref is shown here at 152 knots. Pilots normally fly 5 knots faster than this speed to allow for changes in wind. If the wind is very strong or gusty, pilots may fly more than 5 knots than Vref, but no faster than Vref plus 20 knots. This speed of Vref plus 5 to 20 knots for wind is the speed that is also called final approach speed. If an aircraft is not close to this speed at 1,000 feet in IMC or 500 feet in VMC, the approach is not stable and a go-around must be made. All flight speeds and the vertical flight profile is calculated by the flight management computer and is called VNAV. VNAV means vertical navigation. This is the end of this presentation video about aircraft speeds. Please now watch these two videos at the links shown here, and these links are also in the PDF file attached. For the 777 ILS approach video, if you want to just see the approach as the flaps are deployed, just watch the video from 9 minutes 30 seconds in. Thank you for watching.